So for my precision calculations, here is my triplicate, and here are the numbers that we collected for measuring the triplicate. And I've also got a duplicate standard, which will tell me the variation from within the method. So that'll be the concentration of 1000 given here, and the duplicate value is given here. I'm just going to copy these numbers across into Excel. We've got our 1000 standard, and we also measured that as 1004.757. And for the instrument, we measured in triplicate. These numbers are 1073. Okay, so the first two numbers give me the overall variation, because we had two different technicians making up dilutions completely independent of each other. That'll give us an indication of how much variation there is within the method. Second set of three numbers were just three consecutive cuvettes of exactly the same sample, so that'll give us an idea of how much variation we're getting from the instrument. So for each of these, we'll calculate the average and standard deviation. So the function is average. Double click on average and just these two numbers. Similar for standard deviation. It's stdev.s. Pass the two values and hit enter. Similarly for the instrument, I'm going to calculate an average and a standard deviation. So average, once again, and standard deviation. Okay, and now to calculate our RSD for each of those metrics. The best way to display this result, standard deviation as a fraction of the average. Note, I didn't multiply by 100, but I'm going to format the cell as a percentage, so Excel will automatically turn the calculation into a percentage. And I will add extra decimal places there. And for the method, we have RSD of 0.34%. And then for the instrument, we have standard deviation as a fraction of the average and as a percentage. Value comes out at 0.54%. Each of those is a measure of the precision, or if you like, the variation that is in the process. The other thing to calculate is the accuracy. So I've got to go to the CRM, the reference material, and also our measured value for the CRM. So CRM is given as 2500 ppm. Now we actually measured 2525. It's a percentage error calculation that will give us an idea of how the accuracy is going by calculating percentage error. So that one is equals, open the bracket, the measured value minus the true value. So all of that bracketed to calculate the difference in the two as a fraction of the true value. And I want to present it as a percentage, so I'm going to, rather than, as I said before, multiply by 100, better just to format the cell as a percentage, and Excel will automatically multiply the fraction by 100 and present the percent symbol. And we have an error of 1.03%, which I'd suggest is acceptable, within the acceptable range. So each of those, these are our quality metrics, if you like, for the quality of our analysis. All the numbers are well under 5%, so we can be satisfied with the results that you guys collected. Now back to our check for the variations within the process. We had a 1000 ppm standard that was prepared in this case by Amber, and a duplicate of the standard was also made up, this time by Haley. These results can help us understand overall variations in the final result due to the materials and the method. The problem with the original RSD calculation is that a value of 1000 ppm was used for the standard. But unfortunately this number was not measured, it was a nominal value. However, the reading that was taken as a measurement was the absorbance value. So to improve the RSD estimate, let us use the absorbance readings to estimate the variation. And so the RSD calculation will go like this. The measured absorbance for the 1000 ppm standard was 0.181. And for the duplicate, we recorded an absorbance of 0.184. Pass these two values to calculate the RSD of the method. Now for direct comparison, I've done the same for the instrument. So you see here now that the instrument readings are also absorbance readings. And in this way we can compare the results and the amount of variation that's been introduced by the various parts of the process.